disconnected or what? Meanwhile, when we were solving the problems?
Yeah, ma'am. Actually, I had to go somewhere, ma'am, and actually it was already too late, so I wasn't
Correct.
able to
You
inform
informed
you,
me for
ma'am.
that, right? Yeah, that's okay. But then you should inform me, like I have certain things and I supposed to go. You should inform me that, isn't it?
Yeah, yes, ma'am. But I was getting late, ma'am, so I didn't even have time to say you that, ma'am. Or else I was thinking to say you, ma'am. But then again, I was solving questions, so I did not.
Okay, okay. Fine, no issues. Fine. Now, we are going to see the next problem, which we have mistake left that day. You were not there for this beryllium problem as well, right? Beryllium and aluminum problem, isn't it?
Yeah, I will not, then,
Yeah.
ma'am.
Only you're there. And what about the other students? Why they have not joined yet? Jaswant and Dhananjay?
No idea, ma'am.
Okay, fine. No issues. Um,
I think they will join in few minutes or something.
yeah, but then always late, that won't be fruitful, right?
Yeah, yes, ma'am.
Fine. No issues. See here. This problem already I have discussed with those students. Only you were left because of the certain network issue or maybe your emergency, as you said. So what is the problem? Beryllium and the aluminium exhibit many properties which are similar, but the two elements differ in beryllium and aluminium, right? These two elements, they have many similar properties, but then they are differing what? That we have to see. So you have an option. First option is what? Exhibiting a maximum covalency in a compound, then exhibiting a amphoteric nature in their oxides, then forming a covalent halides and forming a polymeric hydrides. So now, as we know that beryllium and aluminium, these two elements in the periodic table shows the diagonal relationship. What does it show?
They should diagonal relation.
As they have a diagonal relationship among them, they have a similarities in their properties. But then if you see the beryllium, its valency is +2 and aluminium, its valency is +3. They are
Plus
different
three.
covalencies,
Yeah.
right?
Yes,
Yes.
ma'am.
So your option one is more matches with the difference, exhibiting a maximum covalency in a compound. They are
Why
differing.
can it not be the second one also? Because
No.
aluminum oxide is an amphoteric,
Oxide be
beryllium it
formed
cannot
by
be.
only aluminium. Beryllium does not form amphoteric oxide. Okay.
Yeah, ma'am. So that is what the difference is in them, right, ma'am?
Yeah, exhibiting amphoteric nature in their oxide, that's true. But then both should be show that those properties, na, both should be differ in those properties. Like that it should be.
Oh,
See here, it's already
okay.
given explanation for my solution. Whatever I'm explaining you, for that explanation is already there. Wait a minute, I'll show you. Let me scroll it down. Fine.
Yeah, yes, ma'am.
Check it here now. Ah. Beryllium belongs to the second period, correct? And the aluminium belongs to the third. As a result, they are different electronic configuration. They are different in their electronic configuration, atomic number, right? And beryllium and aluminium have a different covalencies. Fine. Because
Yes.
beryllium has a +2 and aluminium has a +3. Beryllium and aluminium have a diagonal relationship. They possess a similar properties, but they differ in exhibiting a maximum covalency in a compound. And hence, your option first is a correct one. Because covalent halides, both they have not formed, they are formed covalent halides, both they have a polymeric hydrides, right?
Right, ma'am. Yes.
AlH3, then the beryllium is a BeH2, right? And even for the amphoteric nature of the oxides, somewhat similar properties due to diagonal relationship. But then here, covalencies differ for the both. Beryllium would have a +2 and aluminium would have a +3. Got it?
Yes, ma'am.
Yeah? Fine. We'll move to the next question now. Yeah. You were not there for this question as well, I guess. Which is the correct order of second ionization potential which is the correct order of second ionization potential of carbon, nitrogen, oxygen, and fluorine in the following, right? What they asked
Yes,
you?
ma'am.
Second ionization potential, not the first ionization potential. Understanding? What do you mean by the first ionization potential? Means the amount of energy required to remove one electron from the outermost shell. And the second ionization potential means amount of energy required to remove second electron, means first already removed. And then again you try to remove the second. That time how much energy you would require. That is the second ionization potential. Understanding? For
Yes,
example,
ma'am.
carbon, its atomic number is 6, right? And its electronic configuration would be what? 1s2, 2s2,
2
2p2.
piece
Correct?
3. Yes, ma'am.
Correct? 2 to 4 and to 6. Right? For the nitrogen, it would be 7, 1s2, 2s2, 2p3. Correct?
Yes, ma'am.
Right? For the oxygen, atomic number 8, its electronic configuration 1s2, 2s2, 2p4. Right? And for the fluorine, 9, it would be 1s2
H2, 2H2 and 2
and 2p5.
5.
Correct? Yeah. Now, in this case, if I have removed one electron among all this, so number of electrons in the outermost shell for the second ionization potential would be, what it would be? Instead of 2 here, 1. Correct?
Yeah, yes, ma'am. They all be reduced with one
Yes.
electron.
One electron we are going to remove. So now it become what? 2. Here 3 it was. This 4 will become 3 and this 5 will become 4. Correct?
Yes, ma'am.
Now for the second ionization potential, what would be the easy? For the carbon, if you see, check here, 1s2, this orbital is completely filled. This orbital is completely filled. So easily this one electron from the p shell can be removed for the second ionization potential, correct?
Yes, ma'am.
Yes. So it requires less energy. Yeah.
Right, ma'am.
And if we go for the nitrogen, here are the 2 electrons, right, in 2p orbital. And once it will be lose its one more electron, means if you have to remove one more electron from this, it may require more energy as compared to carbon. So carbon require less energy as compared to nitrogen. This
So, ma'am,
would
if
be
we
the,
do like this, then the fourth option will be correct, right, ma'am?
it's not like that, beta. I'll show you because there are certain like things which we need to discuss yet. I'll let you know what. Let me get
Okay,
it,
ma'am.
scroll it down, okay? I'll scroll it down. I'll show you. Because all the solutions I have with me, I just wanted to discuss with you thoroughly. Wait a minute. I'll clear my drawing over here. See, they haven't show you your first orbital. 1s2 is not given over here. You can check it out, whatever we have written the exact
Yeah,
thing.
yeah, yes, ma'am.
Correct? Yes or no? So these are the electronic configuration for carbon, nitrogen, oxygen, and fluorine for the outermost shells. 2s2, 2p2, 2s2, 2p3, 2s2, 2p4, and 2s2, 2p5. After removing one electron, it would be remain what? C. Carbon will become 2s2. Carbon will become what? 2s2, 2p1. Right? Nitrogen become 2s2, 2p2. Oxygen become 2s2, 2p3, and fluorine become 2s2, 2p4. Now, what about the carbon C? It will occupy the ideal gas configuration, means the inert gas configuration when it loses one electron from the p orbital. Correct? Right or
Yes,
no?
ma'am.
Because of that, it has very low second ionization potential. Now, when we go for the nitrogen, it will have only one electron in the outermost p subshell. After removing second ionization, after removing electron for the second ionization potential. Correct? So it may have a more energy as compared to carbon. It may require more energy as compared to carbon. Now for the oxygen, it will have 2 electrons in the p subshell. After removing second ionization potential, it's very unstable and so it will have a high ionization potential. Why? Because in p orbital there would be 2 electrons after removing one more electron from the 3. Correct?
Yes, ma'am.
And here we occupy the stable half-filled configuration because as we know that 2s electron. This is 2s2, and 2p3 would be here. Once among these
They
four, one
these
would,
both are completely filled.
yeah. It become half filled. 1, 2, 3. So one electron would be
Yeah,
occupied one,
yes, ma'am.
right? So as it is
Yes,
half filled, what happened? It is stable configuration.
right,
So
ma'am.
energy criteria would be what? Carbon require less energy as compared to nitrogen. Nitrogen require less energy as compared to your stable half-filled fluorine,
Fluorine.
right? And oxygen, as it has two electrons, it become highly unstable. So we
Yes,
have to
ma'am.
group up and take our options, correct?
The first option will be right.
No, no, need to check. Oh, wait a while. Yeah. So oxygen has a higher energy to fluorine. Nitrogen has a higher energy as compared to carbon. Yes. So your first option is the correct one.
Yes,
Clear?
ma'am.
Understood? In this way, you're supposed to solve all the answers. Shall I erase it?
Oh, yes, ma'am. Yes.
I hope you have written. Fine. We'll go to the next question now. Dhananjay and Jaswant, quietly they have joined. No introduction, nothing, ma'am. We have solved this. Don't want to say hello, hi, good afternoon, something you should say or not. How I come to know that whether you have joined?
Good afternoon, ma'am.
Ah, means I have to greet you, right? Yeah. Quietly you will join, quietly you will leave. How I come to know whether you're present or not? Okay, no issues. Go for the next question. The group having isoelectronic species. Isoelectronics means, come on, tell me the meaning of this isoelectronic. Yeah? Yeah? The group having isoelectronic species. What do you mean by isoelectronic?
Same number of electrons in the outer shell.
Number of electrons in the all given ions, right?
Yeah,
Yes or no?
yes.
You should be aware of the atomic numbers of each and every atom. Correct? They have given all the same atoms, only charge is different. Correct?
Yeah, yes, ma'am.
Yeah. So oxygen, atomic number is 8. Then the fluorine, atomic number is 9. Then sodium, its atomic number is 11. And magnesium, its atomic number is 12. So we'll go for one option each. Oxygen O minus 2. So minus 2 means whatever negative charge would be there on the head, that many electrons you're supposed to add into atomic number. Because atomic number is equal to number of proton present into the nucleus of an atom, which is equal to number of new electrons present into the atom, correct? So 8 electron plus these 2 extra added with a negative charge. So 8 plus 2 is equal to 10 electrons, correct? Yeah. Fluorine with a minus 1 charge. So 9 plus 1, that is equal to what? 10 electrons. Then sodium has 11 electrons, right? But then here would be the charge plus. So that plus charge need to be subtract from the
Yeah.
atomic number, because
So it's
plus
10.
charge is nothing, removing of electron from the given atom. So that is equal to 10. And here Mg has a plus 2 charge or 2 plus charge. So in that case also 12 minus 2 is equal to 10. So you come to know in a first option only all the species, ionic species which are given that have a same electron means they are isoelectronic. Clear? Yeah. So your option 1 is
Yes,
the,
ma'am.
please write down if you want. Yeah. Correct, Dhananjay. I will scroll it down. See, here is the answer which is given to you. If you want to take a screenshot, you can. It's up to you. Now go for the next question. Which of the following oxide is amphoteric in character? This question 10. Which of the following oxides is amphoteric in character? Calcium oxide, we know that it's a metal oxide. It's not an amphoteric at all. Carbon dioxide, it is non-metal oxide. It is also not amphoteric. Silicon oxide, silicon is just below to the carbon. It is also not amphoteric oxide. So what does remain? Stannous oxide, tin. Correct? It can react with acid as well as base.
So there are more amphoteric oxides other than aluminium and
Yes, yes,
zinc.
yes. Aluminium, zinc, stannous, many more are there. You can check into the periodic table list. You'll come to know the which metal will form the amphoteric oxides. The option stannous chloride SnO2 would be a what? Amphoteric oxide. Please write down.
If we like don't know anything else other than aluminium and zinc, then how are we supposed to like know it, solve
For
it
that
then?
reason only we have to study in deep, na beta. And second
Okay,
thing is
okay.
what we should be aware of about this calcium oxide. It's a metallic oxide. It's a basic in nature.
Yeah. If we do the
Acid,
elimination thing,
acid
then we can get it.
react only with acid. It does not react with base. Second thing, carbon dioxide is acidic oxide, right? And it will react only with base. It does not react with acid. Silicon, silicon is also like it's just below to the carbon, right? So silicon also shows the similar properties like a carbon. So it is also from acidic oxide, right? It does not react with base. And hence your option would be fourth, stannous oxide, because it can react with acid as well as base. So reactions also you can surf on the Google if you want for that. So you will get the clarity about it. Fine. Check it. See here. A molecule of iron that can react with both acid and base is called an amphoteric compound. And hence, stannous oxide is an amphoteric in nature because it can react with both acid as well as base. Please raise down. Write down. Clear? Now see the next question. Which of the following atom has the highest first ionization energy? Which one? Here, scandium, rubidium, sodium, and potassium. You should be aware of the atomic number of. Come on, tell me the atomic number and the electronic configuration of each. Are you there, students?
Yes, ma'am. Yes, ma'am. Scandium atomic number is 21.
Come on, tell me atomic number for this. I think potassium would be at
Potassium is 19. Sodium is 11. Scandium is 21. And rubidium, I don't know, ma'am.
Now here scandium and rubidium. Tell me.
Scandium is 21, ma'am.
And rubidium. Write down their electronic configuration now.
Rubidium atomic number will be 37.
Huh?
37.
37. Okay. Write down their electronic configuration now.
Yes, ma'am.
Okay, fine. Write down the electronic configuration. And it would be what? I hope that would be this argon. Okay, 18. 4s2 become 20 and 3d 1, correct? These are 20, okay, together. For the rubidium, it will be again argon, then 4s2, it become 20, right? And remaining 7 will go into what? Sorry, it will be krypton. It will go to the krypton. Because somebody said me for the RB, it would be how much? 37, right?
37, ma'am. Yeah, ma'am.
Yeah, so let me check. 37, okay? And its electronic configuration would be krypton, not argon. It will be krypton because it's we should cross the 30, right? Krypton, and here 5s2. So for the krypton, it would be how much? 36, right? And 5 years 2, no, it should be 5 years 1 because that it is 37, correct? Now for sodium and potassium, all of you are aware that's really very easy, right? For the sodium atomic number 11, I'll write it here for the sodium 11. Yeah, 2s2, 1s2, sorry, 1s2, 2s2. Come on, write down. Tell me. 1s2, 2s2, 2p6. How much? 10, na? And here it will be what? 3s. 3s, how much? 1. Correct? For the potassium, 19. Go for it. 1s2, 2s2, 2p6, 3s2, 3p6. How much? 4s, 1. Right? You can see here 3s, 1. Here 4s, 1. And here it is 5s, 1. But then if you see for the scandium, electrons are present into the 3D shell, right? Yes, students, are you there with me? Plus one,
Yes,
Dhananjay,
ma'am.
Prayasi. Check it here, what I'm telling you. If you see the electronic configuration of all four atoms, like sodium, potassium, scandium, and rubidium, Rb, right? Here you can see sodium has an electron into the 3s orbital, outermost electron. For the potassium also electrons are present into the 4s1
For us,
shell.
electron.
Yeah. And then if you can see it, even it is present into the 5s1 shell, means s orbital only for the potassium as well. Only in a scandium, if you see it is present into the d orbital.
D orbital.
So what you have to keep it in your mind, you have to keep in your mind about this poor shielding effect, right? Poor shielding effect would be shown by only two orbital, that is d orbital and f orbital, right? So among this, only d is present into the scandium, right? And rest all
Yeah,
into
yes.
s. And more shielding effect would be shown by s and p orbital, right? That is also write down. More shielding effect shown by what? S and
P and
p
S.
orbital. Okay. So whenever your electron into the d orbital, it requires high ionization energy to remove one electron. Understand? Because that electrons are into d orbital, and d orbital require a high energy to remove from that particular shell. Okay. And hence you have a high energy into the high ionization potential high in the scandium as compared to rest all three atoms. Clear? Fine.
Yes, ma'am.
Fine. Now you have to go for the next question. I have erased without asking you. I hope you have written, correct?
Yeah, ma'am. Yeah, I'm done, ma'am.
Fine. We'll go to the next question now. See now. The lanthanide contraction is responsible for the fact that zirconium and yttrium have about a same radius. Then zirconium and nobelium have the similar oxidation state. Zirconium and hafnium have about the same radius, and zirconium and zinc have the same oxidation. Now, zirconium and zinc combination will not be applicable for this question because zinc is not a part of lanthanide family. Correct? Yeah. Then zirconium and nobelium have the same oxidation state. This is also not true, right? And zirconium and yttrium have about the same radius. This is not same because zirconium and hafnium have the same radius, right? If you go
Right.
to the lanthanide series, zirconium and hafnium have same atomic radius, almost same atomic radius. So your option third is correct in this case. If you don't, if you're not aware, please note it down because these lanthanide and actinide we are going to see in detail in your inorganic chemistry. This is just a periodic property, so I'm not going to focus much about it now, right? But then when we are going to learn about the lanthanide and actinide series separately as a chapter, that time you will aware about it. Shall I erase it?
Yeah,
Hello.
yeah, done, ma'am.
Fine. Now we'll move again for the next question. Check this. The charge or size ratio of a cation determine its polarizing power. Which one of the following sequences represents the increasing order of the polarizing power of the cationic species K plus, Ca2 plus, Mg2 plus, and beryllium 2 plus? See here now, the spaces which are given to you, that is K plus, Ca2 plus or no, plus 2, magnesium 2 plus, and beryllium 2 plus. Correct?
Yes, ma'am.
They give you the charge or size ratio of cation. Charge and size ratio of a cation determine what? Its polarizing power. Means they already gave you hint how you have to check it. Correct? Yes or no?
Yes, ma'am.
Charge versus size ratio of a cation determine its polarizing power. Which one of the following sequence represent the increasing order of polarizing order, right? Of the polarizing power of cationic species. So you should be aware about the atomic number of each first to means to determine the size. So atomic number is more, then its size is also more, correct? So for the beryllium, I guess it's 4, magnesium it is 12, calcium it is 20, and the potassium it is 90. Correct?
Yes, ma'am.
Yeah. Then you can check their size as well. Sorry, here charges as well. Here +1, then the +2, then here +2, and here also +2. Correct? Now we
Right.
know that the size and charge ratio is less for the beryllium because size is less. Correct? Yes or
Right.
no? Yeah. Then next would be what? Magnesium. After that, potassium and then the calcium. But then potassium and calcium have just one atomic difference. One there it is differ by only one number, and that's why we have to check like what changes should be taken, whether calcium would be first or I'm sorry. Right. Yeah, check it here. What is given? I'll clear it. Yeah.
They are
Gives,
given for potassium.
yeah. They have given this uh, potassium has a higher ion ratio, size and ion ratio as compared to calcium 2 plus. Why it is so? Because in the potassium, only one electron has been removed, right? And in calcium, there would be two electrons are
Two.
removed. Means
Yeah.
potassium has a more negative side, more negative charge, right? As compared
Mm.
to calcium. Because here only one electron has been removed and here two electrons has been removed, right? So more
Yes,
negative
ma'am.
charge have a more radius, right? And as it has a more radius, its charge and size ratio is also more. So it will be more polarizing as compared to calcium, right? Yes or no? And because of that, more is the charge or size ratio, higher is the polarizing power. And hence your sequence would be potassium has a more polarizing power, then the calcium, then magnesium, and then the beryllium. Because it has less size, greater size. This is the greatest size, but due to the plus two charge, we have to keep what? Your potassium first. So in this way, you have to solve this problem. Fine? Clear? Yeah. Somebody has written
Yes,
the answer.
ma'am.
Okay. Now again, we will move forward. The next question. Yeah. Write down this. Iron exhibit plus 2 and plus 3 oxidation state. Which of the following statement about the iron is incorrect? So read the statement one by one. Let me see what logic you will apply for this question. Question number 14. Iron exhibit plus 2 and plus 3 state. We know that if iron is exhibit plus 2 state, it is Fe plus 2 means ferrous.
Yes, ma'am. If it's plus
Fe
3,
means
then it's
what? It is
ferric.
plus 3. Fe plus 3, that is ferric. Right? Ferrous and ferric, correct? Yeah.
Yes.
See the statement. Give me a while, student. Give me a while. Fine. See here, ferrous oxide is more basic in nature than the ferric oxide. This is your first statement. Huh? Ferrous oxide is more basic in.
That's correct, ma'am.
Wait a minute. What they asked you? Incorrect.
Yeah, yes, ma'am.
Which statement about the iron is incorrect? Okay, so this is the correct statement. Then the next one would be what? Ferrous compound are relatively more ionic than the comparing ferric compound. Ferrous compounds are relatively more ionic. That's correct. Ferric compound is plus 3 and it will go to with oxygen which has a minus 2 charge, but then ferrous will go with the less number of atoms of oxygen.
Yes, yes, ma'am.
Right. So this is also correct. This is correct. This is also correct. Now ferrous compound are less volatile than the corresponding ferric compound. That is also true. Ferrous compound is less volatile. Ferric compound are more volatile. You know that ferric compound only would be present into the rust. Correct? The last one is given what? Ferrous
Yes, ma'am.
compounds are more easily hydrolyzed than the corresponding ferric compound. So this is somewhere not true because ferric has a plus 3 charge, right? Ferrous has a plus 2 charge. So plus 3 charge means with more charge, species of iron can be hydrolyzed more effectively as compared to ferrous,
Yeah,
right?
yes, ma'am.
Whatever they have written, that is completely opposite. And hence it would be your incorrect statement. So let's see what is given to you. Oh, sorry. Your option 4 is, yeah. As we move down, the alkali group size increases. This was the, no, this wasn't that problem. See here. Ferrous compound are yeah, less easily hydrolyzed than the ferric compounds, and ease of hydrolysis is inversely proportional to the electropositivity. So we come to know if ease of hydrolysis is there, so your electropositivity would be less. And if hydrolysis are less, means electropositivity would be more. Means vice versa. Clear? Yes. So
Yes, ma'am.
that statement you're supposed to write. Which one? I'll let you know. This one. Not this one. This statement. The ease of hydrolysis is inversely proportional to the electropositivity. Fine.
Yes, ma'am.
Student, it's 4:30. I wanted to complete these, but then I'll post these questions directly in our assessment. So from there you can download and please write down the answers for same.
Okay,
So
ma'am.
would you like to continue with a few more questions of same chapter, or shall I jump to the next chapter now? I'm asking you all four. I need your suggestion. If you want same,
Next chapter.
Okay, ma'am. We, sorry. Oops.